Today's unit is on solving radical equations. We will look at how to determine the roots of radical equations algebraically. We will talk about um, what are called extraneous roots, and we'll go through a process that'll let us solve these types of equations. Okay, so a radical equation, I'll show you what that is and how to solve it, and we'll discuss what an extraneous solution is and how to identify these types of solutions. Okay, so we'll start out very basic, and we're going so a radical equation, first of all, identify, well, what is a radical equation? A radical equation is an equation, so that means there'll be an equal sign, where the unknown, the variable that you're trying to solve for, will be below a radical sign. So it'll be part of the radicand. So you notice here the x is here. This would be a radical equation. Versus, let's suppose I had this. Now, sometimes students will mistake and say, oh, I understand. Radical equation means there's a radical in it. No, not necessarily. For example, I'm going to erase this in a second, but if I had x minus the square root of 6 equals 2, this is not a radical equation because the unknown is not a radicand. This is an equation that has a radical in it, but it's just a linear equation where I'll be solving for x to the first power. Versus this scenario where the unknown is below the radical, that becomes a radical equation. All right, so having said that, if it is a radical equation, I have a set of steps over here that you can go through. And again, if you had to come back and refer to this in the video, you could. First thing you're always going to want to do is isolate a radical, meaning get it all by itself on one side of the equal sign. Then the next thing you're going to do is raise both sides to some exponent that will eliminate the radical. Then the next step after that is you would examine that new equation and go through a series of steps to solve that new equation. Now it'll usually be linear or quadratic, both equations that you have dealt with in the past, so it should be something you can manage once you get through that eliminating the radical part. And then the last part is you're going to check your solution, which we'll just call that the verifying step. Okay, so let's start with this one, which is going to be quite basic. Step 1, isolate the radical on one side of the equation. So I look this over, well, that's already done. This radical is already the only thing on the left side of the equal sign. So that, done. Raise each side of the equation to the same power. And you want it to be some exponent that will get rid of the radical. Well, if you have a square root, that would mean you're going to square both sides. If this had been a cube root, you'd want to cube both sides. So again, like any equation, whatever you do to one side, you must always do the same thing to the other side. When you square a square root, you get rid of your radical. Square this side, you're at 9. Move your 6 to, so that's raise each side. Then it says solve the resulting equation. Well, this would be the resulting equation. Notice it no longer has a radical sign on it anymore. This is just a regular linear equation. This would be a real easy one from back in middle school days. So 9 subtract 6, x would be 3. Now, the last step here, which sometimes we do it if we have time or if we wanted to verify, in radical equations, you must do this. Not just if you feel like it, you have to do it. So I'm just going to write here verify or check, whatever you want to refer to it as. And what you're going to do is take your answer and fill it in for x. And the way you do this is you go ls, which stands for the left side of the equal sign, rs, which stands for right side of the equal sign, and we're going to substitute our answer in for x and see what happens. On the left side, instead of x, we're going to put 3 in its place. 3 plus 6 is 9. Right side, started out, I'm at the top line here. Right side was 3. Notice I'm not putting an equal sign between them yet. That's the goal. I want to see, does the left side in turn end up being the same as the right side? If so, my answer is a valid answer. If it doesn't, this would be what I refer to as an extraneous solution. We'll run into those as we progress through this. The square root of 9 here is 3. Left side equals the right side, which implies Our answer is good. That would be the solution to that radical equation. One thing I'll mention here, I have it on the next slide, but I'll mention it here. You always make sure when you're doing this, you do what's called the principal square root. Because when we did quadratic equations, the square root of 9, there was a point in that where we said, oh, it could be plus or minus 3. And depending on the scenario, yes, it could be plus or minus 3. But when you're doing verification of your solutions, you always only deal with the principal square root. And the principal square root is always the positive version. Square root is the positive version of the two possibilities. All right, so when we're verifying, we're only going to deal with principal square root only. All right, so what will happen now is we'll just kind of go through a series of examples and progressively get a little bit more challenging, and hopefully you'll develop kind of the skill set. So the steps are still up here. That'll eventually disappear, and we'll have to kind of figure this out on our own. If we, let me see here. If we look at this one, when students will first look at this one, sometimes they'll say, well, this isn't a radical equation. I don't see a radical. What you need to remember from prior work is that radicals, so for example, the square root of x could be written as x to the exponent 1/2. The cube root of x could be x to the 1/3. The fifth root of x to the 7th is x to the 7/5. So yes, when I look at this, there is no perfect squares, square roots. However, there is a fraction exponent. So a fraction exponent is a radical in disguise. So we're going to have to treat this as a radical equation. Now the key here is going to be for us to decide what exponent are we going to have to raise both sides to in order to eliminate this fraction exponent. There's two ways you can go about it. You could switch this to a radical and say it's the cube root of this squared. Or what's probably easiest to do is just understand that if you multiply, so with exponents, if I have x cubed and I raise it to another exponent, well, I'm going to multiply those together and the result would be x to the 15. Well, if I'd like to know what x is, so if I had x cubed and I wanted to raise it to some exponent so that I get what x to the 1 is, well, I would want to raise it to some number so that when I multiply these two together, I will get a 1. Well, that number in this case would be 1/3 because 3 times 1/3 gives you 3/3, which is equal to x to the 1. So if we kind of put that into a bit of a rule, what we will say is under these conditions, if you have something in brackets, some variable, to a fraction exponent, to eliminate the fraction exponent, what you'll want to do is raise both sides to the reciprocal of this ratio. So in this case, 3/2. This side, 3/2. Because if you take 2/3 and multiply by 3/2, let's just put it up here, 2/3 times 3/2, well, the answer is 6/6, which is equal to 1, which is what I want. I want 3x plus 4, now just to the 1. This means take the square root of 16 and then raise it to this exponent. So that's going to give me 64. Square root of 16 is 4, 4 cubed is 64. Now solve the resulting equation. So I've removed, again, it's not per se a radical, but it is a radical in disguise. So I have to raise it to the reciprocal, raise both sides to the reciprocal, solve for x. In this case, x turns out to be 20. Verify and see how that actually works. So on the left side, if I put 20 in where the x is, I'm going to get 64. So eventually you can kind of start speeding these up. Don't show all your work. So 3 times 20 is 60 plus 4, 64. to the 2/3. The right side is already a 16, so I don't have to do any work on that side. Just put here, right side, 16. Let's check this. The cube root of 64 is 4. And then I'm going to square it. It works. So that is our solution, x equals 20. Now, I just wanted to throw that one in there. We don't run into it too often, but you may run into that situation where you've got some variable raised to exponent and you're trying to solve for it. So, just throw another one by hand underneath here, just off the top of my head. So, for example, just in case you're ever doing something, and I'll make it quite easy. Let's say I had x to the 3/4 equals 8. And I was trying to solve that. Well, all I would do is raise this side to the reciprocal, do the same to this side. 3/4 by 4/3 is x to the 1. Cube root of 8 is 2. 2 to the 4th power, 16. So I would know here that x has to be 16. Right, so you're more likely to see it in this kind of a context. All right, so let's jump back now to our radical equations. Well, what are we going to do if there's more than one radical? We're just going to go through our list of rules, which rule number 1 with solving a radical equation is to isolate one of the radicals. It does not make any difference which one. So in this case, I've got 2 to choose from. One here, another one here. So I'm going to isolate one of those 2 radicals. I'll pick this one, get it by itself, take this one over to the other side, square both sides, get rid of the square root. Now conveniently, there's nothing else there on this side. Started out with a 0, which made it a bit easier. If you square this, you get 2x plus 1. You square this, you get 10 subtract x. Solve for x. 3x equals 11. X is equal to 11/3. Now the verifying of this one's a little bit uglier because of the fraction. Let's see how this goes. So the left side is 22/3 plus 1 minus, put 11/3 in here for x. So 10 minus 11/3. And if this works out right, I should get 0. 22/3 plus 1/3, that is going to be 25/3, because 1 is 3/3, minus, so 10/1 is 30/3, minus 11/3 is, something's going wrong here. Let's see, what's 2x plus 1. I verify this isn't working out. Well, maybe it's extraneous, but let me check again here. So it's 30/3 minus 11/3. That'd be 19/3, which is not giving me 0. Did I mess up one of these? Let me double check here. Square this one. Square this one. Bring this here. Oh yeah, right here. This should have been. This should have been 9, not 11. I had to subtract 1. That's going to change things. It's going to make this a lot easier too. That's another reason why you verify. Find mistakes. So this should have been 3x equals 9, x equals 3, which will make this much easier. Now let's double check and redo this. So now if x is 3, let's check our verifying. Square, so this is the left side. It will be 2 times 3, which is 6 plus 1, square root of 7, minus 10 minus 3, which is square root of 7. The right side is 0, 0, all good. Now, you may run into a situation, so you can kind of see that I kind of got puzzled for a second because here, these were not working out. You may run into a situation where these do not work out, but I thought I could remember from doing this question in the past that it did work, so I kind of figured I had made a mistake here. But if you go back and double check this, and you get, what you believe is the right answer, and then you come over here and it's not verifying, that can happen. That would just mean that this answer is extraneous, which means it works here, but it doesn't work up here. We'll run into that here in a moment. All right, let's continue on. Okay, this one, we've got our radical. It's already isolated. There's only one radical here. So I got x minus 2 equals the square root of x plus 10. Well, the radical is isolated. It's the only thing on the right side of the equal sign. So our next step is square both sides. Squared and squared. Really important. Here is by far the most common mistake students make, is they do not square binomials properly. They just square this number and square this number. And I've showed you this over and over. I'll use numbers to show you why you can't do that. If we had 3 plus 4 squared, I think all of you would agree that that is 7 squared. The answer should be 49. Well, this x is just taking the place of the number. So watch if you go over here and try and do what many of you will sometimes do here. Square this one and square this one. Well, if I did that here, 3 squared would be 9. 4 squared would be 16. When I add 9 and 16, I'd get 25, which is not right, which shows me if I cannot do it with numbers, you cannot do it with algebra or variables, because a variable is just taking the place of a number. So make sure when you square a binomial, 3 steps. Always, always, always. Square the first. Multiply and double. Square the last one. Now this one is not a binomial squared because this whole thing is one square root sign. So when you square one big square root, it just gets rid of that square root sign. All right, so notice the difference. This one's not a binomial. Even though there's a binomial under the radical, I'm just squaring the radical first. So that gets rid of the square root sign. Well, this time, unlike all the other ones so far, we've generated a quadratic equation, which is fine. We just solve it using our strategies from unit 1. So x squared, subtract 5x, subtract 6 equals 0. Find two numbers that multiply to give negative 6. Same two numbers add to give you negative 5. Would be x take away 6. X plus 1 equals 0, giving me two possible answers. X may be 6. Maybe x is negative 1. All right, now this is where verifying becomes, it's always critical, but here there may be a chance that one of these answers or both of these answers are extraneous. So I got to check that. And again, it's not if you have time or if you feel like it, it's part of radical equations. It's this extra bit at the end where you verify your answers. So let's check 6 first and see how that works. Put it in the original. Don't put it in here. Put it in the original question. The left side will be 6 minus 2, which is 4. Notice I'm not putting an equal sign, I'm just putting a line there. Right side, the square root of 6 plus 10 is the square root of 16. And the square root of 16 is 4. Remember, we're only going to do principal square root here. We're not going to do the plus or minus bit. All good. I'm just going to put a check mark by 6. I'm going to now check negative 1 and see what happens. So if x were to equal negative 1, check the left side, check the right side. Your goal is to see if they are the same or they are different. Left side, if I put negative 1 in for the x, negative 1 subtract 2 is negative 3. There's the left side. Now the right side, I believe is x plus 10 below the square root sign. Yes, the square root of x plus 10. So if x was negative 1, it's going to be negative 1 plus 10, which is the square root of 9, and the square root of 9. And this is where it's important to realize we're only doing principal square root. So I would get a 3 here, which means that these two are not the same, which means this answer worked. This answer is what we refer to as an extraneous solution. Watch the spelling of it. A-N-E-O-U-S, an extraneous root, which means it's a solution that works in the equation you generated after you get rid of the radicals. However, it does not work in the original equation that involved the radical. All right, so that's your introduction to what we refer to as extraneous solutions. And you don't, just because you get two answers does not necessarily mean one of them is always extraneous. I've seen examples where they both work. I've seen examples where one's extraneous, the other one works. I've seen examples where neither one of them work. So you have to verify all the possible answers and see whether they actually are a legitimate solution or they are an extraneous solution. All right, let's have a look. Here's another one. I'm going to move things around. And you can always move things any way you want. I think I'll move just, if I have to get too many negatives on the go, it can maybe sometimes cause problems. I'm going to move this one over here, make it n plus 7, and move this term all over to the right side, which will become positive square root 5 minus n. Square both sides. This is a binomial squared, so 3 steps. Square the first, multiply and double, square the last. This is one single radical being squared. That will get rid of the square root sign. It's quadratic, much like the last one, so let's move things around. N squared plus 15n, subtract 5, so plus 44 would equal 0. Now I want to multiply and get 44 and add to give 15. So that's going to be 11 and 4, n plus 11, n plus 4. Two possible answers. Notice I say possible, because I'm going to check here in a minute and see if they are. So there's my two possible solutions. We're going to verify them in the original question. Remember, verify in the original question. Here's my verifying. Let's try n equals negative 11 first, see if it works. The left side will be negative 11 minus the square root of, this is the left side, 5, subtract a negative 11 will be the square root of 16, which will be negative 11 minus 4, which will be negative 15. The right side is negative 7. That didn't work, which means that one is extraneous. And you do have to label it extraneous. Make sure you write out that word, point at it, circle it, whatever it is you're going to do to identify that that is an extraneous solution. Let's try negative 4. All right, left side is equal to, back to the original, so it's n minus 5 minus, so n minus the square root of 5 minus that number, which will be 9. And the right side is negative 7. Negative 4, take away the square root of 9 is 3. Negative 7, that one works. So there is my solution this time. Negative 4, negative 11 turned out to be extraneous. Alrighty. Just quickly show you this one. So isolate a radical, 4x minus 7. Bring the 10 over, get minus 3. Now, sometimes students are kind of clever enough to look here and say, wait a second, this can't happen. I can't take the square root of something here and get a negative answer if I'm only dealing with principal square root. So I can just tell by looking at this, there's no way that I could take the square root of this and get a negative unless I'm getting into non-principal square root. You said, what if I don't notice that? Well, watch what happens if you keep going. So you just keep going, square both sides. You get 4x, take away 7 equals 9, 4x equals 16, and I get x is 4. I verify it. Left side, if I put 4 in where the x is, it'll become 10 plus the square root of 9, which will be 13. And the right side, when I check here, is a 7. Those are different. Therefore, this equation even I only got one answer, it doesn't work. It's extraneous, which means this equation is impossible. It has no solution because the only one we got turned out to be extraneous. So you can have equations that have no possible solution. All right, so now we're going to try and put this all together into a question that may be a little bit more complicated. So I've got two radicals. I need to isolate one of those radicals. Well, the fact, sometimes people say, well, I'm going to have to get rid of the two. No, that's okay. This is considered one term. It's like having 2x equals 7x plus 5. Well, this could be considered one term, a coefficient and a variable. So radicals can have a coefficient and a radical. That's all considered one radical. So this radical is already isolated on the left side. Well, we're into our steps. Square both sides. All right, now, as stated earlier, I said square both sides. For example, if I said to you, 7 equals 4 plus 3, I think you would agree. However, if you tried to say, well, I'm going to square both sides, and you did it this way, squared this one, and squared this one. 7 squared is 49, 4 squared is 16, 3 squared is 9. Uh-oh, that doesn't work. You can't just go along and square each one individually. The rule is square both sides. Notice how I put the brackets on the left side. Do the exact same thing to the right side. Put brackets around it and square it. Don't go along and square each one individually. That is, again, a very, very common mistake. As I showed you over here, you can't do that. Doesn't work. All right. Squaring a single radical. Square the coefficient, the number in front, and then square the radical. Left side, that one's easy. Now, you may have to rewind your video, pay close attention here. This is a binomial this time because it's one, a number, then there's a plus sign. See here the difference? There's no plus or minus here, which makes this all considered one radical. So I could square the coefficient, square the radical. This one is a binomial. You've got a term here, separated by addition, and then another term here. So you must follow the 3 steps to squaring a binomial. Square the first. There's the first square. Multiply this by this. Now this is a non-radical, and this is a radical. So you can't, when you multiply them together, now 1 makes it even easier, but let's say that had been a 5. If I had said this times this, the answer would have been 5 radical 2x plus 9. Because one's a radical, the other one's not a radical. So here it's 1 times this, which would just be 1 square root 2x plus 9, doubled 2 square root 2x plus 9. There's step 2. Square the last. Well, this is just a radical. So when you square a radical or a square root, it just gets rid of the radical. Well, let's clean up what I got here now. I've got 4x plus 16. I've got 2x plus, got a 9 here and a 1 here, plus 10 plus 2 square root 2x plus 9. Well, this is the first time that this has happened, that we've squared both sides, but notice there's still a square root left here. So things have got a little bit more complicated now. Well, this process becomes like a computer loop that they call recursive. If you isolate and square both sides, like I've done, and there is still a radical left, you start over. I don't mean the question, I mean the steps. You're going to isolate the radical that's left and then square both sides again. So it may take multiple iterations of you isolating and squaring both sides. Now, don't be discouraged and say, oh my goodness, there's still a radical left. But the good news is you started with 2, now there's only 1, which will allow us to isolate this radical and move everything else to the other side. So I'm going to move these 2 over here, which make this now 2x plus 6 equals 2 square root 2x plus 9. At this point, you've got a couple options here. I would only ever do this if everything divided. So for example, here too, these are all divisible by 2. You might want to, you don't have to do this, but you might want to say, I'm going to divide everything by 2 to make the numbers a bit smaller before I square both sides, which will then make this x plus 3 equals square root 2x plus 9. Now we're ready to square both sides again. Squared, squared. I'm not sure what this stuff is down here, but let's get that over here. Okay, so I'm squaring both sides. And that's going to give me, square the first, multiply and double, square that one. This is all one radical. So when you square it, all right, so after doing this the second time, no more radicals left. Now it's a quadratic. Set it equal to 0 and solve as we normally would. X squared plus 4x equals 0. Well, this will make for easy solving because the only thing you can do with two terms is take the greatest common factor, or if it could be different squares, which it's not. Take out your x times x plus 4. This multiplied by this, answer is 0. Could only happen if x was 0, or perhaps x was negative 4. Now I got to verify and see if these work. So remember the numbers are 0 and negative 4. Let's check them out. X equals 0. Left side. If I put 0 in here, 2 square root 4. The right side, put 0 in here, 1 plus square root 9. Square root of 4 is 2 times 2 is 4. Square root of 9 is 3 plus 1 is 4. 0 works. Now I got to check my other answer, which I think was negative 4. Now I got to check negative 4. Negative 4, put in here. So negative 4 plus 4 would be 0. Square root of 0 is 0 times 2. Left side is going to be equal to 0. Left side would be 0. The right side, put negative 4 in for the x and see what you get. Negative 4 times 2 is negative 8, plus 9 is 1, so I'm going to get 1 plus the square root of 1. 1 plus square root of 1, which is going to be 2, does not work, which means negative 4 is an extraneous solution. This one we can identify it by its proper name. It is an extraneous solution. All right, let's have a look at another time through one with two radicals in it. Let's try this one. Isolate one of the radicals. Doesn't matter, they're both similar. So I'm going to take this radical and move it over here. Square root 3x plus 1 equals 3 plus. So I've isolated one of the radicals. Square both sides. Remember, don't square each one individually. Square the entire side. Put the whole side in brackets, squared. When you square this one, you'll get 3x plus 1. Binomial, first term, second term. Follow 3 steps. Square the first. Product of these two, I'll just jot it down over here, would be 3 radical x minus 4. That's first times second. These two multiply together. Then you got to double it. That means times it by 2. Well, when you multiply by 2, it doesn't affect these. It's only going to affect the number in front. So that's going to be 6 square root x minus 4. There's your middle term. So multiply, you get that. Then double it. Times it by 2. You double the number in front only. Don't touch the radicand. This would be plus 6 square root x minus 4. Square the last one. It's a square root. When you square a square root, you just get the radicand. Still have a radical left. So move everything to the other way. So I got 3x. I'm going to take away x. That'll give me 2x. I've got 1. Over here, I get 9 minus 4, which is 5. So I'm going to have to take away 5. That's going to give me a subtract 4 equals 6 square root x minus 4. Again, at this point, check your coefficients and see if there's any common factors. If you find them now, it'll make things easier going forward. Notice these, 6, 4, and 2 are all divisible by 2. Let's take that out as the GCF. And we're down now to x minus 2 equals 3 square root x minus 4. Square both sides again. Binomial squared. Square the first, multiply and double, square the last. Notice this one's always a plus, first and last, because you're squaring them. Over here, it's not a binomial. Just because there's a number in front doesn't make it a binomial. It has to be 3 plus or 3 minus to be a binomial. This one is just a radical term that has a numerical coefficient. Square the numerical coefficient and then square the radical. Now, no more radicals remain. Set it equal to 0. Tidy it up a bit here. X squared, take away 13x plus 40 equals 0. Two possible answers. You want to multiply to get 40, add to give minus 13. Subtract 5 and subtract 8. Giving me two possible answers. Oops, didn't want to do that. Back here. Two possible answers are 5 x equals 5, x equals 8. Now I have to check those and see if they verify in the original. Go back to the original. Scroll up so I can see here. Let's put x equals 5. I'll check it over here. 3 times 5 is 15 plus 1. This is the left side now. The left side is going to be the square root of 16 minus 5 take away 4 would be 1. 4 minus 1, 3. Right side, 3. That one works. The other one was 8. Maybe I'll try fitting it over here. You'll see my equation. So if I check x is 8. Left side, 3 times 8 is 24. Adding 1 is the square root of 25. 8 minus 4 is the square root of 4. Our right side is still 3. Square root of 5, or 25 is 5. There's one where they both work. So even though I got two answers, we did not discard one of them. This is a radical equation that had two possible solutions. They both worked. Neither was an extraneous solution. Okay, so there are some examples showing you how to solve radical equations involving starting out just a single radical, evolving to multiple radicals, where you may have to isolate the radical and square both sides multiple times before you can get rid of all of your radicals. So what I'm going to ask you to now do is use your textbook to get some further practice. I'm going to skip that. Here are questions in our textbook. Now, this is any single possible question that covers radical equations. I think your basic ones kind of start here in the beginning, just to get yourself comfortable with them. In a day or so, I'll come back with an assignment on solving radical equations. So hopefully you've used some examples in your textbook to just get some practice in on these. All right, so that is the end of radical equations.